All right, let's begin with our new unit. This is Unit 9. Unit 9 has everything to do with sequence and series. Before we begin today with our lesson, I want to draw attention to a formula sheet that has all the important formulas and some common breakdowns about this entire unit. This can be found on the Google Classroom under the resources as well as the Canvas platform. So here. So what we're going to be dealing with today is a thing called arithmetic sequences. But let's first break down what the heck is going on here. All right. So there are different types of sequences and things like that you'll see a common pattern in a list of numbers. So for instance, if I have a pattern that goes something like this, 5, 8, 11, etc., etc., etc. All right. And I asked, hey, what if you had to guess what the next number is? What would you guess? Kind of idea. Okay. And so what you can do is you can break this down, and you can see, oh, I see what's happening. How we're going from one number to the next is a +3. And so that would imply that this next number would most likely be 14, et cetera, et cetera, et cetera. Okay, this is a list of numbers. How things are kind of denoted by this is this. A with the subscript n is what this is an element of a number sequence. Okay, where n is the element number. So, for example, this is the first element, this is the second element, this is the third element, this is the fourth element, this is the fifth element, et cetera, et cetera, et cetera. Right? So this 2 is technically a 1. This 5 is technically a 2 because it's the second number of that set. A 3, a 4, et cetera, et cetera, et cetera. All right, so what a subscript whatever is a number. It's a number. Okay? And then n, again, is the element that you want to talk about. All right? So, if indeed you add a number to get from one to the next, this is an indicator that this is arithmetic. If, for instance, you would multiply to get to one number to the next, okay, this would be an indicator that this is quote-unquote geometric. Now, are these the only two different types of number sets? No, there's patterns that, are a little combination of both and stuff that we aren't even talking about. So it's not exclusive that these are the only two sets. However, in this chapter, these are the two types that we are going to be talking about. All right, so arithmetic is the pluses and the minus. Geometrics are the multiplies and divides. Now, okay, let's start there. Is this sequence arithmetic? All right, so what all arithmetic sequences have to deal with each other is they add a common number again and again and again and again. Okay, so this common number is known as the common difference. Let me write this in a different color. And the common difference is denoted by lower script d. And how this is found is, in essence, you take the second element, or an advanced element minus the one right before it. Okay, so very technically, this is what it is. Now, again, kind of a quick and dirty version of what I do is I take the second number minus the first number. So in our example above, what I would do is I would take A2, which is the second number, that is 5, minus the first number, which is 2, which is 3. So that would say our common difference is 3. And then that's easily checkable by literally doing what we did here. If you continually add 3, you keep coming up with the correct answer. So back to the actual question. So if this is arithmetic, this would indeed have a common difference, which would be -7 minus 23. The second term minus the first term, which comes out to be -30. Now, if I, in this case, subtract 30 minus 30 every single time getting to the next number, then we're okay. So for instance, 23 minus 7. I'll just use this calculator right here. 23 minus 7. Sorry. 23 minus 30. Sorry. 23 minus 30. -7. Okay, good to go. Minus 30. -37. So far, good. So good. Minus 30. -67. Okay, so we're hitting all of these numbers exactly by minusing 30. Thus, yes, this is arithmetic. Number 2, same question. So let's go ahead and find that common difference. So I take the second number minus the first number. So that's -29 minus -21, which is -8. So if I minus 8, okay, so -21 minus 8, -29, okay, good to go, minus 8, -37, uh-oh. Okay, that one's not what it's supposed to be. That number should be -37. And then minus 8, it doesn't really matter anymore. Minus 8, -45. Okay, that one hits. But notice how this -31 is not what it's supposed to be. That -31 should have been -37. So if there is a mistake in the sequence, then that implies that no, this is not arithmetic. It has to be -8 every single time. Okay. Now, let's talk about the explicit formula. Okay, so we talked about the common difference. Okay, and again, the quick and dirty version is A2 minus A1. Okay, or a more advanced element minus the one right before it. This next one is called the explicit formula. What the explicit formula, again, it's on the formula sheet here, is AN is equal to A1 plus the common difference of N minus 1. A little bit of quick manipulation. This thing is the same thing as saying difference times N plus A1 minus the difference. It's the same equation, just kind of manipulated a little bit. Okay. What this explicit formula does is this. If I see a sequence going on here, all right, let's say I do have an arithmetic sequence the first number is 2, and let's say I'm adding 3. So that would be 5 and 8, et cetera, et cetera, et cetera. Okay. Or this is A1, this is A2, this is A3. And I want to jump way into the future. I want to jump way into the future and know what A of 63 is. What is the 63rd number of this set? Okay, what is the 63rd number of this set? All right, this is where the explicit formula is used. You can jump to whatever number that you need as long as you have the appropriate information. So for instance, do you have the difference? Okay, so here that would be 5 minus 2, which is 3. So yeah, we do have a difference, and this is indeed arithmetic. Do you have A1? Do you know what the first number is? Yeah, the first number is 2. Very well. And then do you know what number you want to jump to? Yeah, I want to jump to 63. So that is in essence saying that I want to make n 63. So how I would use the arithmetic formula, the explicit formula, is this. An is equal to the difference, n plus A1 minus b. So in this situation, I want to know what is the 63rd number. So the difference times the number that I want to jump to plus A1 minus the difference. And then just literally plug that in. If they want the explicit formula, what that is asking for you to do is this. You're not looking to jump to any specific number, you're just trying to jump to a number, and if you're asked to just write the equation, then all the letter n's will stay the letter n. So I see that the letter D is 3, A1 is 2, D is 3. So long story short, this explicit formula would be an of 3n minus 1. So if they straight up want the formula, then this is what they're looking for. You're not looking to jump to any specific n, and all the letter n's will stay the letter n. Okay, here they give us the explicit formula, and they want us to use it to find the first, the second, the third, the fourth, the fifth, and the 52nd. All right, so let's find what is the first element, A1, the first term. And so that would be negative 100 times 1 plus 76. Okay, the second number is negative 100 times 2 plus 76. Again, I'm just going back to this equation, and I'm making n the number that I want it to be. And the third number. Now, what I notice here is that there's a difference, and what is happening is a minus 100 every single time. Okay, so the difference is negative 100. So what you can do, if you see this, is you can use it to your advantage. So the first number is negative 24. You kind of have to figure that one out. Then I see that the second number was negative 124. Knowing that this is arithmetic, that was minus 100. So if I minus 100, minus 100, minus 100, you can get that pretty quick. Now the 52nd number, you may want to go back to the formula and use the formula just one more time. So the 52nd number, I'll do it right here front and center, is negative 100, and I'm looking for the 52nd number. There you go. Okay, number 4 is the exact same thing. Oops. Number 4 is the exact same thing, but just with a different arithmetic formula. Okay, so let's find that first number. Switch colors here. And so this is negative 10n, which the first number is 1, minus 26. And then the second number, negative 10. So I see that this is a minus 10 type situation. So I start off with negative 36, minus 10. And so that will turn out to be negative 56, negative 66, negative 76, et cetera, et cetera, et cetera. And then the 52nd number, okay, here we're asked 3 different questions. What's the common difference? What's the explicit formula? And what's the 52nd number? All right, so the common difference, that's an important term. And so what I do is I take the second number minus the first number. Okay, that's the common difference. Okay. What you need to know right now is also straight up the first number that is going to be necessary to write this explicit formula. All right, the explicit formula, I'll use my abbreviated version. All right, so this is going to be the common difference, n plus a1 minus n. So that's 23 minus negative 30. Let me kind of shrink this down just a little bit. And now we get the 52nd number. Okay, so the common difference was negative 30. The explicit formula, an is equal to negative 30n plus 53. And the 52nd number is negative 1507. Okay, so put it in repeat. So the difference is going to be 2 minus 9/4. The first term is 9/4. The explicit formula then the 52nd number oh, I see what I did wrong. Sorry. Okay. Careful, I had to make sure everything is in parentheses. All right, so here we go. The common difference was -1/4. AN is equal to -1/4 n plus 5/2. And the 52nd number is -21/2. Again, what I do is I just minus going up that direction. So I see that that's quickly 24 plus 10. You do it a few times, you kind of get a feel for it. You kind of skip out some of the writing. All right, find the explicit formula for the arithmetic sequence with the common difference of 4 and whose first term is 1. So the common difference is 4, the first term is 1. So AN is equal to the difference, n plus 1 minus 4, which is -3. 1 minus 4 is -3. Sorry. 9 minus 3 is 6. So again, I've been doing some quick math in here. Here's, in essence, what I'm doing. So what I'm after is AN is equal to DN A1 minus B. All right? So what I'm doing is I'm starting with AN, so I start with the difference, 3, so 3N. And then I'm taking A1 minus B, so 9 minus 3, 9 minus 3. That's what I'm doing kind of quickly, which is a positive 6. Huzzah, you got yourself your equation. So common difference is -2. First term is going to be 1. So AN, so the difference, n, and then 1 minus -2.